Repeat once again. The 8051 timer and counter. The 8051 has two timers, timer 0 and timer 1, and they can use either the timer or as counter. So both the timers are 16-bit wide. So 16 bits, though 8051 has an 8-bit architecture, but its timer and counters registers are two separate registers, combination of low byte and high byte. And the timers of 8051s are named as timer 0 and timer 1. They can work separately for particular operation. To set the timers or counters, the T-mod registers are required. To use the timer and counter, you have to first assign the value of T-mod registers. Based on the value of T-mod register, the 8051 counter will work. So timer 0 is basically 16-bit register and it consists of low byte and high byte. So TL0 indicates that bit from 0 to 7 as TL0 and TH0 indicates from D8 to D15. So the lower bytes is indicate TL0 and higher bytes indicate TH0. Similarly, the timer 1, look at the timer 0 is for 0, this is the indication, and timer 1 is the indication that this is the higher byte of TH1, this is the lower byte of TH1. Now how the T-mod register you assign the value? The T-mod register is an 8-bit register. So this is the T-mod register. It has two part, timer 0 part and timer 1 part. Look at the combinations are same, gate C by T bar, M1 and M0. The gate value indicates if it is 1, then the external setup, external trigger is required, that when the gate value is 1, then a hardware value is way to setting and the stopping the timers by an external source. So when you use gate equals to 1, then external trigger is required, and when gate equals to 0, when the gate value equals to 0, it is software defined. Now C by T, look at the T is bar, means it is the 0. So when you can use the timer, then this value obviously 0, and if you want to use as a counter, then the C value will be 1. So this 0 indicates that it used as a timer. If I use 0 here, then it indicates the gate is software trigger. But if I use 1, then hardware trigger. M1 and M0. M1 and M0, this is the value of M1 and M0. The M1 and M0, when you use 00, then we call as a mode 1. The function of the mode 1, that it is a 13-bit counter. So 13-bit counters, that its maximum value it able to count from 0 to 1 FF. Why 0 to 1 FF? For that you have to go this register, that 13 bits. So these three upper bits are not work. So actually it start from XXX to 0. This is the first 4 bit. Then 000. This is the TH0 part, and again these bits are 0 0. So 1 2 3 4, 1 2 3 4. So that's value 2 XXX 1 0 0 0 0 2. Oh sorry, it will be 1 1 1 1. How many ones? 13 1. 1 2 3 4 5 6 7 8 9 10 11 12. That's mean these 4 F, again these 4 F, these 4, I miss one F, these 4 F. So in short form you can write this value is 1 F and this is FF. This is 1 F, this is 1 F TH0, and this value is for TL0. So this is the operation for mode 0, and for mode 1 it uses a 16-bit timers. And after the 16-bit timers, that we can do it by set bit timer 0 for timer 0 and set bit timer 1 for timer 1. Set B TR0 means set bit timer 0, and set B timer 1 for timer 1. So it is actually loaded with a 16-bit initial value. So 16-bit initial value you can use, and after that you can use that CLR TR0, clear timer 0, and CLR timer 1 means clear timer 1. Now mode 2 indicates that M1 equals to 1 and M0 equals to 0. So it is again a 8-bit timers. Look at that, set B timer 1, set B timer 0. In similar way you can select the mode. And mode 2 is actually 8-bit timer. So mode 0 is 13-bit timer, mode 1 is 16-bit timer, mode 2 is 8-bit timer, and mode 3 is the split mode timer. You know that split timer? The timer 0 and timer 1 may be programmed to be mode 0, 1 and 2 independently. So you can independently program the timers. So the timer do not operate independently if the mode 3 is chosen for timer 0. Timer 0 is not truly operating mode 3. The placing timer 1 in mode 3 causes that it stop counting, and the control bit TR1 and the timer 1 flag are used by timer 0. So this is the program. So this part is very important. Get clear the mode 3. The mode 3 is also known as split timer. The timer 0 and timer 1 may be programmed to be in mode 0, 1 and 2 independently. So you can use as mode 0, mode 1 and mode 2. Of the similar mode for other timers, this is not a true for mode 3. Why? Because the timer do not operate independently. Timer operate togetherly. So if mode 3 is chosen for timer 0, suppose you say that I use the timer 0, that is 13 bit. So 13 bit is not work because the pressing of timer 1 in mode 3 causes it to stop counting. So it stop counting. So if you program, then there will be no error, but its operations will be differ. So the control bit TR1 and timer 1 flag TF1 are then used by timer 0. So that's why it is not possible to continue. So in this class we learn about the basic of timer. In the next class we will do that how the timers are used for program. Thank you.